Question 25. The diagram shows a semicircle and an isosceles triangle which have equal areas. What is the value of tan x? Lots of options here. If they appear to look like exact trig values, then you are right. We're looking at triangles. We can look at a right angled triangle. Let's see where we get to. So the area of the semicircle is a half pi r squared. This semicircle here, but we don't know what r is, so I'm just going to call it r for now. Okay, so that's that dimension, that's the radius of that semicircle. The area of the triangle will be r multiplied by h. Now, technically it's half rh multiplied by 2, but let's just call it rh. And so we know that this area equals this area. So these two I can put equal to each other. I can divide both sides by r. So that h is pi r divided by 2, or if you like, half of pi r. So we now have an equation for h in relation to r. We now need to relate that back to the angle though. So we have certain bits of information. So if we look at this triangle just here, this is x. We know this is h. We know this is r, but also h is the same as pi r squared. So we've got those two in relation to each other. And hopefully we're going to end up with the r cancelling each other out, because r is just a letter that we've put in here. But let's see how we get on. So using our TOA triangle or our tan, this is our adjacent. Make sure you get it the right way around. This is your opposite. So tan x is going to be the opposite over the adjacent. Now the opposite is your h and the adjacent, which is your r, but we're going to put pi r, half pi r in here, divided by r, and yes, look, those r's are going to cancel out. So they're going to divide to 1, so we're just left with a half pi, which is also written as pi over 2, and therefore the answer is E. Now, I'd call this a beautiful question. It is one that you put a letter in and a letter just sort of pops out the other end. What did we do? Well, we knew that these two areas were equal. We worked out using an r in here and an h here for this height. So we put that information in. We worked out the area of the semicircle, knowing it was half of the whole circle. Area of the triangle, which we just did, r multiplied by h. We then put them equal to each other. This formula here, this equation here, where we put the two, we put them equal to each other, and then we rearrange so that we've just got an h equals. Then when we come to using trigonometry, we're looking at our adjacent length and our opposite length. Tan x is going to equal the opposite length divided by the adjacent length, h over r, and then the r's cancel out, and we're left with just pi over 2.